to Eternal Easy Education. In this session, you are going to learn Chapter 6, Specification and Abstraction. Content of this video is Algorithmic Design Techniques. Among the algorithmic design techniques, you are going to learn what is specification. What are the algorithmic design techniques? First one is specification, abstraction, composition and decomposition. Let's learn one by one. What is specification? The first step in problem solving is to state the problem preciously. A problem is specified in terms of the input given and the output desired. That means, in our terms, a problem is a question. So, if it is a question, then we need, as a computer science student, we need the input-output. So, input is the data which is required to do the sum, and output is the expected result. So, the first step to solve the question is the specification. The specification must also state the properties of the given input and the relation between the input and output. That means it has to say what is the input and what will be the output and what is the relation between the input and the output. So these things are given by the specification concept. Abstraction. A problem can involve a lot of details. Several of these details are unnecessary for solving the problem. That means a problem may have many number of steps to do its result. Only a few details are essential. Ignoring or hiding unnecessary details and modeling an entity only by its essential properties is known as abstraction. That means if we are having a car, we know two things. One is if we start the car and if we give the accelerator, the car will move and the speed will increase. We know that. But as a person who is driving the car doesn't know the mechanism behind it. When the accelerator is given, how the engine picks up the speed and how it's moving the wheel is an unknown thing. But there is a need, that means the inner mechanism is not explained. That is abstraction. So, if a problem is having many steps, only necessary thing is given. That is said to be abstraction. What is composition? An algorithm is composed of assignment and control flow statements. Assignment and control flow statement means assignment here giving a value to a variable. So what is a variable? What is a value? Value means the input and the output data. That is the value. Here as I said in the previous video, the data are stored in a place with a name. That is the variable. So assigning a value to the variable is assignment, and control flow statement means if the program is having many number of steps, the control will flow from first step to second step. Sometimes instead of executing the third step, it will move to sixth step or seventh step based on a condition. That is control flow. So it is not necessary for a program to execute the line sequentially. So there is a control flow. That means the flow of the execution of the statement is controlled. So this assignment, that means giving a value and also controlling the flow of the execution or making a combination, that is said to be the composition. A control flow statement tests a condition of the state and depending on the value of a condition decides the next statement to be executed. So while we are writing a program, there will be some necessity to check a condition. Based on that, the program's flow will continue. Decomposition. We divide the main algorithm into functions. That is decomposition, dividing. We construct each function independently of the main algorithm and other function. Finally, we construct the main algorithm using the functions. When we use the functions, it is enough to know the specification of the function. It is not necessary to know how the function is implemented. So the composition, that means assignment, control flow, what is the function, how a program is going to be divided into function, how it should be divided, everything you are going to learn in C++ programming. So all the concepts are going to be applied. Before applying into a programming language, you are learning the basic things. So these basic things are common for C++ or Python or C or Java or any programming language. The concepts are base. So what are the things we have learned? 4 things. Specification, then abstraction. Specification means it gives about the input-output relation of input-output. Abstraction, only the necessary thing. Composition means combination of the assignment and control flow. Decomposition means dividing the algorithm into functions. So these things you are going to apply and write a C++ program. Here only theoretical concepts you are going to learn. So let's see a specification with an example. An algorithm is specified by the properties of the given input and the relation between the input and the desired output. That means a program or a question or a problem is explained with the input, output, what is the input and what will be the output and what is the relation between the input and output. So that things is given by the specification. In simple words, specification of an algorithm is the desired input-output relation. So to write a specification, we need 3 parts. First one is name of the algorithm and the inputs. So we must write a name for the algorithm and the inputs. Then input, the property of the input, that means the quality of the input. Output in the sense the desired input and output relationship. So we'll see the example, then you will understand what are the 3 things. For example, write the specification of an algorithm to compute the quotient and remainder after dividing an integer a by another integer b. That means a simple division sum. There is an integer a and another integer b. We are going to divide it. So they have given an example here as 22, 5. So 22 is divided by 5. So what will be the result means 4 is the quotient and 2 is the remainder. That means 4 5s are 20. So balance is 2. Likewise 15 by 3. That means 3 5s are 15. So the remainder is 0. This is the thing we need. It's a simple mathematical program. Now we are going to apply the concept, write an instruction to form a computer program. That means we are going to form a steps. That means we are going to write the lines to, first we are going to write the statements, then we have to convert the statements to program. So learning the program will come in the 9th chapter. Here you are going to learn only the basic thing. So how to frame a program. So this is the requirement. This is the calculation you are going to do. Let A, capital letter A and capital letter B be the input variables. So first A and B are there. Then we will store the quotient in a variable like Q and the remainder in a variable R. So Q and R are the output variables. You understand? So this is the assignment. Assignment means assumption. We are assuming that the first number has capital letter A and the second number has capital letter B and the quotient as Q and remainder as R. So the input are A and B. When the input A and B is given, there is a relation to form. That means there is a process to get the output Q and R. Okay. So first thing we have to think about, what are the properties of the input A and B? A should be an integer, first point. Next point, remainder is meaningful only for an integer division. And B should not be 0. That means the second number should not be a 0 since division by 0 is not allowed because it is infinity. So we have to set two properties. One is A should be an integer, another one B should not be 0. Next, we will specify the properties of the input as. So we have designed. So how to write means this line is a double slash. The double slash means double hyphen inputs colon A is an integer and B equal, there is a slash. This represents B not equal to 0. Then what is the desired relation between the input A and the B and the outputs Q and R? That means the two outputs quotient and remainder should satisfy the property, which means A equal to Q into B plus R. That means, for example, if 22 and 5, okay, so the 22 equal to Q. What is the Q here? 4 is the Q. So 4 into capital letter B, that is 5. 4 into 5, that is 20 plus 2 is 22. So we are saying that quotient multiplied by the dividend number plus the remainder will form the first integer, as you know, as you have learnt in maths. Then remainder R should be less than the divisor, that is the second integer, or it must be equal to 0. So combining these requirements, we will specify the desired input-output relation as output is A equal to Q into B plus R, and the remainder is less than 0 or less than B. Is it clear, children? So the specification of the algorithm is only the 3 lines. This is the name of the algorithm. Divide, open bracket, A comma B. The first name of the algorithm with the inputs A and B. Next one is the input property. Input property means A is an integer and B not equal to 0. Third one is the output, and the output with the input-output relationship. That is the input A equal to Q into B plus R, and the remainder R should be less than or equal to 0 or less than B. So here the double dash indicates that rest of the line is comment. So this comment is very useful in programming. The comments are statements which are used to annotate the program for the human readers and not executed by the computer. Here we not yet started writing programming, but while you are started writing the C++ programming, you will use the comment many times. So comment means that is not executed by the compiler. Compiler means which is the editor going to execute a C++ program. That editor will not consider the comment line. That is for the humans to understand the program. So you have learned the 4 techniques, algorithmic designing techniques, and one in detail about specification. Then specification as contract. That means specification of an algorithm serves as a contract between the designer of the algorithm and the users of the algorithm. So we must know who is the designer and who is the user. Designer here, you are the designer because you are going to write the algorithm for a program. So the person who is writing the algorithm is said to be the designer, and the person who is going to use that program is the user or the client, because it defines the rights and responsibilities of the designer and the user. So there is a rights and responsibility. What is that? Ensuring that the inputs satisfy the required properties is the responsibility of the user, but the right of the designer. So the user has to say something, what he requires, that is his responsibility. But making it to execute is the right of the designer. Desired input-output relation is the responsibility of the designer and the right of the user. That means if we are saying that A and B and the B should not be a 0 means the designer is taking the responsibility to write the instruction to insist that the second integer number should not be a 0. And That is the right of the user who has given the instruction to the programmer to write the program. Then importantly, if the user fails to satisfy the properties of the inputs, the designer is free from his obligation to satisfy the desired input-output relation. Simply the concept is the person who is giving the work to a programmer, the person who is assigning the assigning the task to the programmer is the user. So he must be very clear how his output should be. That means how the product should be. So he should be clear to say that I need a product with a, for example, if you are buying a dining table, means you should be very clear that particular dining table should be in oval shape. It should be made with the wood, that wood also from the sandalwood or redwood, and it should have a weight of like this and the length of like this, and it should occupy 8 chair or 6 chair. So the customer who requires this thing should say all the things clearly. Okay. Then the carpenter who is designing that is the programmer who is going to write a program, must have some responsibilities as per the requirement of the customer, that is the user. So the property of input is a responsibility of a user and right of a designer, as well as input-output relationship is the right of a user, it is the responsibility of the designer. So this is the relationship between the designer and the user regarding the specification. That's all for this session, children. Take your book, read the things, understand it. There is one more example given in your book. Try to solve it. Thank you. Have a good day.